Welcome to Chemistry 2, Electrochemistry, Lesson 1, Part 1, Video 2, which is based on this diagram of a galvanic cell. So here we have an apparatus that consists of two beakers connected by the salt bridge. So this is a salt bridge. And in this one, we would have a plug that would be like a solid porous material containing some kind of ionic slurry or like a wet solution that allows electrons to flow from one beaker to another. Sometimes we can just have two separate beakers with a strip of paper that's been dipped into an ionic solution that is touching both liquids inside of here. So we're going to label this side first, and it really doesn't matter what side is what as long as we label it accordingly. So we're going to have an electrode of zinc. And if you notice that this electrode is submerged into a liquid, and this liquid has to, or this solution, which is going to be an electrolyte, something that dissolves and gives us ions, has to contain zinc. So this is 1.00 molar zinc sulfate. And I'm going to put an AQ after it because we have to realize that we have a solution here. So in here are going to be floating zinc ions and sulfate ions all through here. And we're going to label this one the anode. On this side over here, we're going to have our cathode. And here we're going to have solid copper, so a strip of copper submerged into a 1.00 molar copper 2 sulfate solution, so aqueous CuSO4. So we have Cu plus 2 floating around and SO4 minus 2 floating around. And in this particular example, and we'll get into why, but if this is the anode, electrons are going to be drawn up in this direction. So I'm going to put electrons. They're going to pass through a voltmeter or a voltimeter. Heard them pronounced both ways. This is going to measure the pull of the electrons over to here because this has to gain them, so this is going to lose them, so it's going to pull the electrons in this direction. So the electrons are going to go in this direction. So what's going to happen here are the copper ions are going to be deposited on the surface of this and become solid. Over here, the solid zinc is going to become zinc plus 2. And if we measure that force, we end up with 1.10 volts. And we're going to look later on how we calculate that. But the overall reaction that is occurring is ZnS plus Cu plus 2 AQ yields Zn plus 2 AQ plus Cus. So the zinc is losing 2 electrons to become zinc plus 2. The copper is gaining 2 electrons to become solid. So that is a redox reaction. So redox reactions are going to be the basis for electrochemical galvanic cell reactions. So that's why we learned them and learned all about them, because in an electrochemical equation, we have to have something losing and something gaining in order to create a flow of electrons and generate electricities in galvanic cells.